Hello friends, welcome to TEQIP GATE classes. My name is Professor Vivek Singh Rathore and I am Assistant Professor in Government Engineering College Bilaspur, Chhattisgarh. And in this video lecture series, I am dealing with Signals and Systems subject, in which we have come across 43rd lecture of this series, and it will be the last lecture of this series. So almost all the portions of signal and system which is there in the syllabus of GATE and ECE of electrical and electronics have been covered, and some portions are left which will be covered today, and still there will be some portions left which are advanced signal and system, that is digital signal processing, and there we'll see the active filters like FIR, IIR filters, we'll see pole zero concept, and FFT will also see. So another faculty will teach that subject, and it will be not so much lengthy. It will be around 3 to 4 lectures or 2 3 lectures only. So almost till now this much you can cover up your signal and system, and you will be able to solve as many as questions as possible. So we'll start with today's session. So let's move on. So see, in the last lecture I was dealing with discrete Fourier transform. Discrete Fourier transform is nothing but a transformation changes from time domain to frequency domain, but in time domain it will be, the signal will be a finite sequence of equally sampled signal. So and that will be periodic only. Okay, so it will be discrete in time domain and it will be periodic, and it will transform also. Then what we will get, in frequency domain we will get same length sequence of discrete, because it is discrete only, and it will be also periodic. So discrete and periodic in both time and frequency domain. This is the concept of DFT, and we have seen how to do convolution also, circular convolution also we have seen in the last lecture. Today we will see some properties of DFT. So let's get started. Properties of discrete Fourier transform. Okay. So first we'll see time shifting property. Time shifting, and we'll see some questions also based on these properties also. So time shifting property. Okay. So see, if f of n is a discrete and periodic, if it is transformed, okay, so we'll see if it is discrete Fourier transform, then what we'll get, f of k, f of k will get, okay, f of k. So when we'll do time shifting in time domain and we will do discrete Fourier transform, what we'll get, f of k will be there only, e to the power generally what we'll do, whenever we'll do time shifting, we'll do e to the power minus j omega, and not like this we'll do. So e to the power minus j, but here k is also there, so k omega means 2 pi by n, into n naught. So like this is time shifting property. So let's do one question and we'll try to understand this property more deeply. So we'll try one question. See, you have been given a sample value like f of n is given, 6, 4 plus 2j is given, okay, and then minus 3 and 4 minus 2j is given, okay. So this is your f of n, okay. Now see, sorry, this is f of k, because see this this is looking like f of k only because it is in frequency domain. We'll see f of k means, I was telling you that f of n is having its DFT value. F of k is like this. So what will be DFT value of f of n minus 3? Okay, you have got the question. If f of n is any signal whose DFT is f of k is like this, so what will be the DFT of f of n minus 3? So we'll try to solve this question. Okay, we'll try to solve this question. See, as you know that if f of n is DFT is f of k, so obviously f of n minus 3 will have DFT value will f of k will be there, e to the power minus j k omega is 2 pi by n, and n is nothing but 1 2 3 4, so 4 will be there into n naught is there 3 है ना, so 3, so it will be 3 pi by 2. Okay, so see, so we can write like this also, f of k e to the power minus j k है ना, 3 pi by 2. So ultimately f of n minus 3 will have DFT value f of k into e to the power minus j k 3 pi by 2. See, f of k is given in your question, f of k is given in your question 6 4 plus 2j है ना, and minus 3 and 4 minus 2j है ना, this value is given. So what you need to do, you need to just multiply with e to the power minus j k 3 pi by 2 है ना. This will lead to means f of n minus 3 will lead to, if we will do discrete Fourier transform, then we will got this type of discrete Fourier transform है ना. This means this is the discrete Fourier transform of f of n minus 3. So let's solve it. See, this is the value of k is equal to 0 value, this is k is equal to 1 value है ना, this is k is equal to 2 value, this is k is equal to 3 value. So see, if you do for k is equal to 0, what you will get answer. See, we'll see 6 is there. Okay, 6 is there, and e to the power minus jk, k is nothing but 0, so e to the power 0 is 0 means 1 only, so first value will remains the same as you have seen in the from DFT, from normal value to DFT also we have seen the value remains the same. Okay, no problem. 4 plus 2j is there, 4 plus 2j is there. Okay, this is multiplied by e to the power minus j, k is equal to 1, so e to the power minus j 3 pi by 2. Okay, next value will be minus 3 e to the power minus j 2 and 2 cancelled, so e to the power minus j 3 pi है ना, and this value will be 4 minus 2j will be there, and e to the power k is equal to 3, so 3 3 is a 9, e to the power minus j 9 pi by 2. Okay, so here we can calculate. See, e to the power minus j 3 pi by 2, e to the power minus j 3 pi by 2 value is nothing but cos 3 pi by 2, cos 3 pi by 2 minus j sin 3 pi by 2, 3 sin 3 pi by 2. And see, you can check the value. See, cos pi by 2 pi है ना, pi 3 pi by 2 2 pi, so the value is minus 1, so minus 1 can be कितना. For sin 3 pi by 2 you can check the value 0 pi by 2 pi 3 sorry okay, okay, I am really sorry, I am seeing the sign value only, this is the sign value, so this will be minus j only, and cos 3 pi by 2 is nothing but cos 3 pi by 2, it will start from here pi by 2 है ना. Okay, from 0 it will start pi by 2 pi है ना, pi then 3 pi by 2 and then 2 pi, so ultimately value is 0, so this value will lead to 0, so ultimately e to the power minus j 3 pi by 2 is nothing but minus j only. So can you do it? Acha, we'll solve all values and then we'll keep the answer. E to the power minus j 3 pi value will be cos of 3 pi minus j sin 3 pi है ना, j sin 3 pi. So what will be the cos 3 pi? It will be minus 1 and this will be 0, so you can calculate it. E to the power minus j 9 pi by 2. Okay, e to the power minus j 9 pi by 2. Okay, this value will be cos 9 pi by 2 minus j sin 9 pi by 2, it will be minus j only. Okay, I think here we have done some mistake. Here sin 3 pi by 2 was minus 1 only, so minus minus plus, so here it will come plus. So let's put the values. So here we'll see 6 is 6 only, 4 plus 2j into e to the power minus j 3 pi by 2, which value is j only, And then we have minus 3 into e to the power minus j 3 pi, which is the value is minus 1. Okay, and next value is nothing but 4 minus 2j, and its value is nothing but minus j. Okay, so let's solve it. The value 6 is there, 4j plus minus 2. Okay, 4j minus 2, and here values is 3 only. Here minus 4j is there, and j square minus plus j square is minus, so it will come minus 2. So ultimately, if I will write here like this, correct answer minus 2 plus 4j, okay, and 3, and minus 2 minus 4j. So this is the answer. This is the actual. For if, see, now if you can understand, if f of n, if f of n was having discrete Fourier transform as 6 4 plus 2j minus 3 and 4 minus 2j, है ना, so f of n minus 3 will have discrete Fourier transform like this. 6 is 6 only. 4 plus 2j is converted to minus 2 plus 4j. Minus 3 is 3, and 4 minus 2j is converted to minus. So see, the variations are there. It will be there. So, but how we have done is more important. How we have done, if you have been given a question, just and you know that if you have to find f of n minus 3, it is a time shifting property will be applied. Just do time shifting property. It's very easy to calculate, and just you need to have focused on it. See, some mistakes are there. I also done mistake, so you may also do mistakes in your exam in doing fast. So just avoid it, and then your answers will be there. One or two options will come, you can directly eliminate other options, and you can put in the right answer. And if mains, if you have to process, then you can do this things. Okay, so after time shifting property, we should move on to our next property. Okay, we should move on to our next property, that is frequency shifting property. As you know, it's just opposite type of thing. So see, frequency shifting property means that if f of n, dft value is f of k, है ना, if its value is f of k, now if you'll do f of k minus k naught, if you'll do in time shifting, and if you'll take dft, है ना, what you'll get f of n. Okay, f of n will be there, and then see, e to the power, for if you will do frequency shifting, just opposite sign will be there. So e to the power jk is there, omega is nothing but 2 pi by n value is there. Okay, and acha, k is here, so we'll do k naught into n. Okay, so see, whatever will be shifted there, that value will come here. So see, f of k minus k naught will have this value, or you can say opposite also. If exponential function is multiplied with f of n, what will have its dft, what will be the dft value, that will be f of k minus k naught. So it's very easy to do it. We'll try to solve one question again, and we'll try to focus on the solution. So we'll see one question. See, uh, if f of n is given in your question, let's suppose 1 2 3 4, this is given in your question, and it is f of n is having uh, f of k dft value. Okay, f of k dft value is given. If f of n is having dft value f of k, then find idft of f of k minus 2. Simple. If f of n is given, and you know that f of n is having dft value f of k, then just find idft value of f of k minus 2. Simple. Let's try it. Let's try it. Okay, so as you know that f of n or I say f of k is having IDFT value f of n. So f of k minus k naught will have IDFT of f of n e to the power j k naught 2 pi by n into n, है ना? This is the frequency shifting. So let's do it. If of f of k was having Fourier IDFT as this value is given, है ना? So I'll write again here. If f of k was having the IDFT value 1 2 3 4, okay, if f of k was having this value, then f of k minus question was f of k minus 2 na, f of k minus 2. So I'll write here f of k minus 2 will have IDFT value how much. So obviously f of n was there, just you need to do multiplication. So let's do it. I'll do it here only. So I'll try. F of n is given, so 1 2 3 4 is given, e to the power j k naught is nothing but 2, so 2 is given, 2 pi by n is nothing but 4 values are there into n value. Okay, this value is there. So 2 to the 4 and 4 is cancelled, so ultimately the value came 1 2 3 4 e to the power j pi n. So now see, this value is nothing but n is equal to 0, this is n is equal to 1, this is n is equal to 2, and this is n is equal to 3. So for different value it will come like, see, I will try here again. This value is 1 into e to the power j pi into 0, है ना? Next value is 2 into e to the power j pi into 1 value, है ना? And next value is 3 e to the power j pi and 2 value, okay? And next value is 4 e to the power j pi 3 value, okay? This is your IDFT of f of k minus 2. So ultimately you can write here as e to the power j pi 0 is 1 only, no problem. E to the power j pi, है ना? E to the power j pi is nothing but cos pi minus j sin pi, है ना? So it will be minus 1 value only and sin pi will be 0 only. So e to the power j pi is nothing but minus 1, so we can write here as minus 2 value, okay? Next value is 3 e to the power j2 pi. E to the power j2 pi is nothing but cos 2 pi minus j sin 2 pi. It will be again one value only, so here we will write here 3 into 1 is 3 only, no problem. And here e to the power j3 pi, e to the power j3 pi means cos 3 pi minus j sin 3 pi, and that will be again, it will be minus 1, so 4 into minus 1 is minus 4. So this is your answer. What answer? See, if f of k was having IDFT, है ना? If f of k was having IDFT as 1 2 3 4, then f of k minus 2 will have IDFT value of 1 minus 2 3 minus 4. You can understand, see how we are doing. I have done one question for in time shifting property also, and one question I have solved for you for frequency shifting property also. So it's very easy. And one more conclusion we are getting, see, I told you for DFT, whenever it is shifted by half of its time period, है ना? See, total time period was 4. After every 4, it was repeating. So what we have done, we have shifted by half only, है ना? We have shifted by half of time period. So see, whenever DFT f of k is shifted by half the number of samples, है ना? In this value f of n, है ना? Or half the number of points in DFT, the effect will be opposite, है ना? The effect in opposite domain is alternate in the sample value. See, plus 1 minus 2. See, you can see f of k is 1 2 3 4. The values are same only, 1 2 3 4, just opposite this is plus 1 only, this is minus 1, minus sign, फिर plus sign, फिर minus sign, like this it will go on. If I will tell now 5 6 7 8, like this it will go on. So if see 8 samples are there, and if you will shift by f k minus 4, then it will go on. See, whenever it is shifted by half of its time period, then the alternate sign will come. So it may be used as a shortcut for your questions whenever if this type of question comes. So first check that if it is shifting by half period or not. If it is shifting by half period, just alternate the sign and do it, no problem with that. So let's move on, and we'll see another property. We'll see another property, third property, that is time reversal. These all property from starting, only from first module we are seeing these all property. I think you must have understood and remembered all the property now. So time reversal property is there. Time reversal property. Time reversal property says that if f of n, if we will take DFT value, we'll get f of k, we'll get f of k. If we'll do f of minus n, if we'll do f of minus n, what will happen in DFT value? So it will be in all the transformation what we have seen from Fourier transform, Laplace transform, Z transform, DTFT, everything we have seen the same effect when we are doing in the time domain, and it will change in the frequency domain. So we'll get f of minus k only, no problem with that. So let's do it with one question, because questions will come in the exam. So how to solve it? See, one question I will see. Let's suppose one signal is there, f of n is there, its DFT value is nothing but 8 3 plus j6, okay, minus 5 and 3 minus j6. So let's suppose f of n is having DFT value something something. Please, you have been asked to find the DFT value, DFT of f of minus n. Okay, f of minus n you have been asked to find. So see, how we'll do it. As you know that f of n is having DFT value f of ka, so ultimately f of minus n will have obviously f of minus k. So just do reversal, means f of minus k you can put it. So how you will do it? The best way you can do it by circular also. See, or you can do like this also, no problem. By circular also I will tell you. See, like this values are there. These values were 8, okay, 3 plus j6, okay, minus 5 and 3 minus j6. This is your f of k values are there. So you can do f of minus k, obviously. I will do here. I told you for minus what you will do, keep the values same in the horizontal and just revert. So 3 minus j6 and 3 plus j6. So this is your answer, 8. The values will be 8, 3 minus j6 value, minus 5 will be there, and 3 plus j6 value will be there. So can you understand that how we are doing it? And as you know, see, f of minus k is nothing but f of abstract of k. And you know, see, f of abstract of k is nothing but f of abstract of n minus k also, okay. So see, here we can use the formula and you can keep the values, or you can do like this also, or you can just move on. See, 3 minus j6, it came here and this came there, rest is the answer. So very easy to calculate f of minus n or f of minus k value, okay. So see, next we'll do spectral density property, because this property also we have seen many times, okay. Spectral density property. Spectral density property was used for calculating the energy. So see, if you could remember, see, the DTFT value, what we used to get, F energy is equal to 1 by 2 pi है ना, for DTFT, minus pi 2 pi mod of f of omega square d omega. This you have seen in the DTFT value. Now there will be some changes with that. Here we can see, as you know, that f of this is not, f of omega was continuous in DTFT value. Here the in frequency domain it is discrete. So if it is discrete, then we will use the summation sign. Summation sign will be there, from k is equal to 0 to n minus 1 will be there, and mod f of k will be there, mod f of k square will be there, and because square, and see 1 by 2 pi means 1 by time period we have seen. So here time period is 0 to n, so ultimately we can do here 1 minus n, 1 by n. So this is your energy value. From this you can calculate the energy value. It's very easy. See why I told you this, because you need to understand where we are using integral and where we are using summation. Summation why we are using, because this f of k was discrete, and here because f of omega was continuous, that's why both are same, but values are same only, like see 1 by time period, so 1 by n is there, from minus pi to pi 1 period they have seen, so here 0 to n minus 1 1 period they have seen, f of k mod square. So we'll try with one question and we'll try to understand this property also. See, see, let's suppose f of n is having DFT value, is nothing but 6 3 plus j2, okay, and let's suppose a value is there, okay, and 6 plus 4 j4 value is there, okay, and then minus 3 b value is there, okay, 2 plus j5 value, and c value. So sum f of n is having discrete Fourier transform like this. A B C is something we'll calculate, okay, no problem with that. But see, where f of n is some real valued signal, what you need to do, you need to find the energy. Okay, so how we'll do it? See, first of all, can you calculate A, B and C value? As you know that f of k is nothing but f of abstract n minus k. This property you know, है ना? So obviously this is f of 0, है ना? Means k value 0, k value 1, k value 2. So f of 2 value will have its value, total n is nothing but 1 2 3 4 5 6 7 8. So 8 minus 2 will be 6. So what will be f of 6 will be the conjugate, taking conjugate will get f of 2. So f of 6 is nothing but 0 1 2 3 4 5 6. So its value will be 2 minus j5. Directly a value have been calculated very easily, है ना? This value will write a value, है ना? We'll write b value. B is nothing but 0 1 2 3 4 5. So f of 5 value, f of 5 is nothing but is same as f of abstract. 8 minus 5 is nothing but 3. So 0 1 2 3 6 plus j4. So we'll take conjugate 6 minus j4. So b value also we have got, है ना? C value, for C value, C is nothing but at the last f of 7 value, है ना? F of 7 is, okay, so it will be same as f abstract. 8 minus 7 is nothing but 1. What is 1? F of 1 0 1 3 plus j2. So we'll take conjugate 3 minus j2. This is C. So ultimately we have got A B C value also, we have got all the values also. Now what we need to find the energy. So energy formula, we know energy formula is 1 by n is there, and 0 to k is equal to 0 to n minus 1 is there, f of k is there, and we will take mod of square. So see, 1 by n is given, 1 by n how much? 1 by 8, है ना? Summation of k is equal to 0 to n minus 1. See, mod of f of mod value we have to take. So what we can do is we can take more, means from 0 to n minus 1. See, from k की value, k is 0, k is equal to 1, k is equal to 2. So k is equal to from 0 to n minus 1, whatever value may be, you just have to do f of k mod, means modulus square. So ultimately I'll put it here, I'll erase it and I'll do the answer. Okay, it's not coming. Okay, so okay, I'll write downside only. From here I will write 1 by 8 will be there. Okay, 1 by 8 will be there, and then what will be there, mod square will be there, है ना? So 6, so okay, 6 is there, no problem, 6 is there. Okay, 6 square, because modulus is 6 only, so square. 3 plus j2 is there, so what we'll do, 3 uh, mod of see, mod value is nothing but under root and then square, so ultimately 3 square plus 2 square, है ना? This value will be there. Next value will be a is nothing but 2 minus j5, so here 2 square plus 5 square will be there, है ना? And next value will be uh, a 6 plus j4 value, so 6 plus j4, so 6 square plus 4 square, है ना? And then the values are minus 3, so minus 3 is mod 3, so 3 square. Okay, and then it will go on. B value, b is nothing but 6 minus j4, so we'll take 6 square plus 4 square. Okay, and then see 1 2 3 4 5 6, two values are left, so we can take 6 minus b value, or 2 plus j5 is there, so 2 square plus 5 square. Okay, and then last value is c is nothing but 3 minus j2, so we'll get as 3 square plus 2 square, and this value will be there. So ultimately, so these values can be calculated and you can get your answer very easily. So see, you can do it, no problem with that. So ultimately, what was the purpose of telling you this? If you have been given a question f of n and its DFT value is something something, you need to find the energy. One way is to find the energy from f of n, which I have told you from in module 1 also, how to calculate the energy of discrete time domain signals. That will be more tough, and you don't know also f of n, you need to find, see, DFT values are there, so it's better that you can do from frequency domain also. Frequency domain is more easy, so just you need to keep the values and you need to get the answer. So this you just the thing is that one formula you need to remember, and rest is the derived form of that, so it's very easy for that. Okay, so here comes to the end of DFT, as DFT is more and more it's there so much, but for exam point of view, this much is enough for you, and rest in the DSP portion it will be dealt. So ending our signal and system, we will see the last topic for it, and we'll see that is response of an LTI system, for sinusoidal input. This is very important, this is very important for conceptual understanding also, and for group delay and phase delay also, so this is very important, है ना? Okay, so see what is happening. The topic suggests response of an LTI system for a sinusoidal input. It means that there is a LTI system, there is a LTI system, and what we are giving, sinusoidal input we are giving. Okay, sinusoidal input we are giving. What will be the response? What will be the response we have to will get is the topic actually. है ना? Now you have understood. See, if you are giving input as a sinusoidal, so obviously sinusoidal will have some magnitude. Let's suppose it will have some magnitude. Okay, it will have some phase, it will have some frequency. This three component you have to remember. any sinusoidal signal will have magnitude, phase and frequency. When it is passed to a LTI system, what will happen to its magnitude, what will happen to its phase, what will happen to its frequency, that is more important, because these questions are being asked in the engineering services pre-exam somewhere in the one-liner question. But many PSUs question, it has been asked what will happen to its frequency, what will happen to its phase. That is very important for you. So let's move on. Let's try to understand. So see, we'll try, see, we'll give cos of omega naught t as input. Okay, it is a sinusoidal, no problem with that. So cos of omega naught t will give as input, and then see what we'll get. Let's suppose this is having impulse response as h of t. So ultimately what we have studied till now, that y of t, what will be output is nothing but cos of t into sorry, convolution of h of t. No problem with that. Obviously cos of omega, sorry, I will tell you, cos of omega naught t, cos of omega naught t convolution with h of t will be the output. No problem with that. Okay, so see, cos of omega naught t, this can be written as, this can be written as real part of e to the power j omega naught t. Okay, no problem with that. Okay, so ultimately see, as you know Euler's function, that if e to the power j omega naught t is passed to a LTI system, what will be the output, what will be the output? See, output will be e to the power j omega naught t will be there only, but see, if it is having impulse response as h of t and its frequency domain, if you'll see, then it will have h of omega, है ना? So here what will come, h of okay. Now what will happen, see, this will happen, let's suppose this is h of j omega, so we can say j omega naught will come. Ultimately let's suppose h of t, its frequency transform, it will do h of j omega, it will come. So now what will happen, just frequency will take place of input, है ना? This is Euler's function. If e to the power j omega naught t is given an input to a LTI system, what will happen? E to the power j omega naught t will come in the output also, with the impulse response frequency domain will have the frequency as same as that of your input. Means if input is having omega naught, it will also have omega naught. This is the thing. So if you'll do, if you'll give real part of e to the power j omega naught t as input, so what we'll get in the output, we'll get obviously the same thing in the output also, real into e to the power j omega naught t, but h will consist of, h will consist of j omega naught only, because see, whatever the frequency is there, that will come in the this portion. See, if you're not understanding, please try to understand. This is h of t is impulse response, and h of t, if you take frequency, so what will come, h of j omega, and now omega is there of impulse response, but in output it will have h of j omega naught. Omega naught is nothing but frequency of the input, so it will do like this. This is Euler function. So ultimately, see, now what I was telling, cos of omega naught t has been given input to a LTI system, and will get some output. So ultimately cos of omega naught t is nothing but real part of e to the power j omega naught t. If we are giving input, we are getting this type of output, है ना? So ultimately what we are getting, I will write here real part of e to the power j omega naught t. If we are giving input to a LTI system, what we are getting output as, see, e to the power j omega naught t. Okay, it's there. E to the power j omega naught is there. Real part is there. Okay, no problem. See, h of j omega naught, h of j omega naught will have some magnitude, will have some phase. So can we write as like this? H of j omega naught can be written as mod of h of omega naught or j omega naught, whatever you can write. No problem with that. Okay. See what real values will take. Okay, no problem. And phase will be mod of e to the power mod of e to the power j h omega naught. Okay, h omega naught means, see, what I am trying to do is h of j omega naught can be written as magnitude and phase. So h of j omega naught, magnitude will be h of j omega naught here, h of omega naught, whatever you can write, mod value, because mod value will be the magnitude value, and it will have some phase. So let's you know that e to the power j omega will have phase as omega. So whatever this value will be there, that is the phase only. So here also h of omega naught phase will come, so no problem with that. Okay, so ultimately if you'll see, we can also write it as e to the power j omega naught t, uh, is there. Magnitude will be there, magnitude will be there, let's suppose mod of h omega naught will be there, this is magnitude, and the phase will be, see, e to the power, okay, e to the power um, j mod h omega naught. Okay, no problem with that. So ultimately what you will get, e to the mod of h omega naught is there, e to the power j, okay, e to the power j is there, and now we can take common omega naught t plus mod of h omega naught. Okay, I think you must have, here it may be seen. So see, what we are doing and what we are getting, you should understand each step. Okay, e to the cos of omega naught t was the input. It means real part of e to the power j omega naught t was the input, no problem with that. It will have output as mod of, see, there will be some magnitude, this is the magnitude, there will be some phase. E to the power j omega naught t was actually uh, the input, only input we got, it was j omega naught t, but its phase will be added with the phase of your the impulse response, so mod of h of omega naught t. So see, what I was telling you that see, I'll write here, if you'll give cos of omega naught t, cos of omega naught t, or if you'll give sine of omega naught t, because this is a sinusoidal input, what you will get, you will get mod of h omega naught, means the impulse response h of t, its frequency h of omega omega, and omega is replaced by omega naught, that will be the magnitude, and its magnitude will be its magnitude, है ना? If it is cos, so we can write cos of omega naught t is there, plus, because see, phase is there, so phase is there plus h of omega naught, so I can write here as cos of omega naught plus h of omega naught. Okay, this, or for sine omega naught t also we can do it as like this, sine of omega naught t plus mod of h omega naught. Okay, this we wanted actually. Now see, now it's the time for conclusion. We have given one signal whose frequency is only omega naught. Okay, it is having one magnitude, it is having one frequency part and zero phase. Okay, so here some magnitude came, means one is transformed to this, because it is actually multiplied by one, so it is only showing this like this, h of omega naught mod, and sine of omega naught t has been changed by sine of omega naught t plus mod of h omega naught. So see, I am telling you what is changing and what is not changing. See, my, it is here. Now tell me, now tell me, uh, is the magnitude changed? Yes sir, magnitude is changed. Magnitude is changed when we are giving sinusoidal input to LTI system, है ना? I'll write here, when sinusoidal signal is given input to a LTI system, what will happen? है ना? This is asked in one line question. You should remember it or you should understand it. When sinusoidal signal is given input to a LTI system, what is happening? Magnitude is changed. Yes, sir. Magnitude is changed. Whatever h of c, whatever it may be, the magnitude will change by mod of h of omega naught. So magnitude is changed, है ना? By or by you can okay, mod of h of omega naught. Tell me, is the phase changed? Here omega naught t plus 0 degree phase is there, but here omega naught t plus mod of h omega naught is there. So I'll tell you phase is changed. Okay, is frequency is changed? See, here frequency is omega naught, here frequency is omega naught. No, sir, frequency is not changed. That is why this question has been asked in many questions, that is the frequency changed? So frequency is not changed when a sinusoidal signal is given input to a LTI system. This is very important conclusion which we have got now. है ना? So ultimately whenever sine of omega naught t will be given as input to a LTI system, है ना, what will be the output? Sine of and LTI system with impulse response as h of t whose frequency is h of omega. Okay, so let's suppose here what we are getting, sine of omega naught t, sine of omega naught t plus h of omega naught will be there, है ना, and here mod of h of omega naught will be there. This is the conclusion that sir, magnitude will be changed, phase will be changed, but the frequency will not change. So now see, now we have got the value which we wanted. Now see, what we can do is, in the output side you see mod of h of omega naught is there. Okay, no problem with that. Sine of can we take omega common, so we'll get t plus mod of h omega naught by omega naught. Okay, so can you tell me that, see, this is t plus t, this is, acha, t plus plus can be written like this also. I'll erase it like this. I'll do it here, t minus of minus like this. Okay, so it can be termed as, it can be written as, see, f of t minus t naught, t minus t naught is there. Okay, t naught t, because see, sine of omega naught t is there. Actually earlier omega naught t was there here, here also omega naught t was there, but now t has been shifted by t minus of minus something, so you can term as t naught, t naught is nothing but mod of h omega naught by omega naught. Okay, and see, okay, I think t naught is minus sign also. So see, this is the delay. Actually if you understand, see, omega naught t, omega naught t, here magnitude is okay, okay, no problem. Sine of omega naught t should come, but t is delayed by minus h omega naught by omega naught. So ultimately the delay is t naught, and the delay is minus h omega naught by omega naught. This is the I can say that, I can say that this is the delay offered by LTI system. ठीक है? Okay, so see, now I'll tell you, this is the omega naught single frequency, here also omega naught single frequency. So okay, so see, and this delay will be called as, this delay will be called as phase delay, this delay will be called as phase delay. So see, now I'll write here, phase delay is equal to, the phase delay is equal to will represent as tau of p that is phase delay, which will be equal to see minus h of omega naught is nothing but the phase only, so we can write here as minus phi of omega by omega naught. Okay, so ultimately phase delay, because see it is delayed only, so I can write here like this, minus phi of omega, whichever phase is there. So ultimately phase delay is the delay in the time domain, which we can see here. Okay, uh, uh, due to single frequency, because see here single frequency is there, so this is called as phase delay. Okay, the delay offered by an LTI system. Okay, phase delay is what? The delay offered by an LTI system to a input consisting of single frequency. मतलब जिस what signal we are giving input, if it is having single frequency and if it is offering the LTI system is offering a delay, then that delay is called phase delay. Simple, no problem with that. Okay, let's move on. If group of frequency, let's suppose this cos of omega naught t, cos of omega 1 t, let's suppose this is input to a LTI system, and now your output will come, something will come, something will go on. So now this LTI system will provide some delay to a group of frequency. Now see, frequencies are more than one. So when LTI system is offering a delay to a group of frequency, that delay is called as group delay. Okay, and its formula will be minus will write here minus d phi of omega by d omega. Okay, this is the formula for group delay. This is the formula for group delay. Okay, so see, okay, this is also called as envelope delay. Now we'll see one or two question and we'll try to understand how we can solve this group delay and phase delay questions. So see, we'll try our distortionless system. So as you know, for a distortionless system, LTI system, what will be there? I told you that magnitude should remain constant and the phase should remain linear. So I told you that h of omega, the phase will be minus omega t naught. This was ideal distortionless system we have seen. Okay, so now this is see, any signal is given as input to a distortionless system now. Okay, distortionless system, we know that it is offering phase delay of this much, means it is offering delay of this much. Okay, phase of this much. Okay, okay, so what will be the phase delay at the output? So let's do it. Phase delay formula, phase delay tau p is nothing but minus phi of omega by omega naught. So see, here the phase is minus omega t naught by input. So input, let's suppose it is omega only, normal input. So omega kata, so it is t naught only. And if we'll see group delay, okay, it is represented by tau g. So it is minus d phi omega by d omega. Okay, and it can be written as, see, minus d phi by omega means minus of d by d omega, and phi omega is nothing but minus of omega t naught. Okay, so it can be written as minus minus plus, only t naught is remaining. So can you see it? For distortionless transmission, the phase delay is t naught, group delay is t naught. So both are for a distortionless transmission. Tau p and tau g are constant and the same thing. It is not dependent on frequency. See, phase delay is not dependent, it is delay on only t naught delay. So there is no dependent on frequency. Okay, we'll see one more question and we'll close up this part. So one more question will be there. Let's suppose any system is there whose phase is mod of h of omega, mod not phase of h of omega is nothing but minus a omega square plus b omega. Okay. Okay, any system is there, let's suppose any system is there whose phase is this one. Okay, and some sinusoidal input is given. Okay, so what will happen, what will be its phase delay and what will be group delay? So let's suppose that we need to calculate the group delay. So we'll calculate the group delay. Tau g is nothing but minus d by d omega of phase. So minus a omega square plus b omega. Okay, so can you tell me that minus minus plus, so 2 of a omega will be there, and here plus b will be there, sorry, minus sign will be there also, minus. So see, its group delay, it is dependent on frequency also, it is dependent on frequency also. So the value is like this only. How to calculate group delay and phase delay? Very easy, minus d phi by d omega, and direct phase delay is minus phi of omega. So like this only we can do, minus phi of omega by omega. So you can calculate the values, it will be easy only, no problem with that. So ultimately we have come to the conclusion of this 43 lecture series of signals and systems. Okay, so big thank you for watching the video lecture. uh, the thank you is not for watching the video lecture, the thank you is for having discipline, that you have come across 43rd lecture and you have seen all the video lectures and you are preparing, you are serious enough for preparing. So for that I thank you, I thank you, and all the best, all the best for your examination. Okay, all the best for your examination. Whatever exam you are preparing, either PSU, either GATE, either engineering services, these lectures will be useful for you in the upcoming exams if you have followed seriously and you have solved questions as many as possible. We have our discussion group also in Telegram. The link of it will be in the description box. You can find it and you can join it. And there you can post questions. If you have any doubts, you can share with us. We'll try to solve it. And thank you and all the best for your exam. And if you have any query or you want to directly contact me, then you can take my email ID, that is vivek.rathor @NIT Delhi .ac.in. Okay, I will not share the number in the this domain because so many fake calls and so many messages will come. So either good way is to keep the email ID. You can share whatever, if you have any personal problem, professional problem, whatever, if I can solve it, then you can share it with me. I'll try to handle it. And okay, so hope we'll meet in the some another subject or in the live doubt clearing sessions or some quiz sessions we'll have. So we'll meet. Till then, last tata, bye bye, see you, have a good day, and Jai Hind.